If astronomers have discovered something with the James Space Telescope, the first question that naturally arises is, what is it? Are we really the only ones in the universe? Or is there something, or someone, else out there? The James Webb Space Telescope has found some amazing finds, discoveries so astonishing that they resemble humans and are located far, far away from Earth. These discoveries bring us closer to answering a question that has echoed through centuries of human curiosity. Many people, across different cultures and generations, have been searching, some desperately, some scientifically, for life beyond our own planet. There are numerous books, an entire genre of movies, and countless imaginative ideas that have been produced on this topic. We, as a species, have always been curious about our place in the vast, mysterious universe. Often, we feel lonely in the cosmic silence, as if we are constantly looking for a friend, someone, or something, no matter how alien they may seem. And now, perhaps for the first time in history, we may even be getting closer to the answers we've always longed to discover. But then the question arises, are they really that scary? The latest discoveries made in galaxies and planetary systems in the search for terrestrial life may, in fact, reveal something we are not yet prepared for. Scientists, through the lens of advanced astronomical technology, have found something that could very well be the most important discovery humanity has ever made. Back in 2021, when the James Webb Space Telescope was finally ready to launch after years of development and anticipation, an interesting question arose about the extent of our technological capabilities. Would our telescopes, as advanced as they are, eventually be able to detect artificial lights on other worlds in the distant reaches of space? Consider this. The closest known exoplanet to Earth, known as Proxima B, lies in what scientists call the habitable zone of Proxima Centauri, a red dwarf star located approximately 4.25 light-years away. Although Proxima B orbits about 20 times closer to its star than Earth does to the Sun, it is believed to have a permanently lit day side and a perpetually dark night side, much like how the Moon always shows the same face to Earth. Imagine an advanced society on Proxima B. Such a civilization could potentially use photovoltaic cells to convert their starlight into electricity, possibly transferring heat and power from the day side to the night side to support life across the entire planet. In a groundbreaking study that included researchers such as Mangnasavi Ligan, it was shown that a future telescope might be capable of detecting solar panels covering much of the daytime hemisphere of Proxima B. This insight suggests that, using the advanced technological power of the James Webb Telescope, we could soon be able to look for artificial light emissions on exoplanets like Proxima B, planets that may harbor life. Thanks to its increased sensitivity and advanced observational capabilities, by the year 2024, the James Webb Space Telescope could already have detected the very light we have been searching for all along. This potential breakthrough could accelerate what may be the next great leap in human evolution. But before we jump to the future, let's step back and understand the nature of the planets and exoplanets involved, so we can fully comprehend how these incredible discoveries are possible. The mission of the James Webb Explorer, or JWE, is clear. It aims to discover what Proxima Centauri B might be hiding. Ever since humanity became self-aware, it has consistently shown a deep interest in understanding the nature of the universe. We have always tried to answer difficult questions about our existence, our origins, and our ultimate destiny. Although technology has advanced rapidly, one might still wonder, are we truly any closer to answering these fundamental questions? A philosopher might argue that our knowledge remains in its infancy. On the other hand, an astronomer would likely be thrilled to recount the latest incredible discoveries made about our universe. Meanwhile, the average person may not always pay close attention to scientific tools and telescopes, but these instruments are, in truth, a real measure of how far we've come as a species. They represent our evolution, not only in terms of exploring the world around us, but also in reaching for the stars above. Scientists and researchers have worked tirelessly to find a way to use modern technology to further this cosmic quest. The recent detection of what may be artificial lights coming from a planet located light years away was made possible due to one specific piece of technology, the James Webb Space Telescope. This remarkable telescope, made possible by the tireless efforts of pioneering space scientists, is now helping us answer some of the most timeless and profound questions about our existence in the universe. Are we truly alone? Where did we come from? And more intriguingly, where are we going? The James Webb Space Telescope, along with its powerful infrared instruments for deep space stargazing, has already begun shedding light, literally, on some of these questions. For example, Proxima Centauri b, sometimes referred to as Alpha Centauri Cb, is a super-Earth orbiting an M-type star. Don't worry if this sounds complex. This video is here to help you understand all the important parts. Planets classified as super-Earths are larger than Earth, but still lighter than gas giants such as Neptune and Uranus. These unique planets, whether rocky or gaseous in composition, typically range in size from 2 to 10 times the mass of Earth. Proxima Centauri b, interestingly enough, is both a super-Earth and an exoplanet, meaning it exists outside our solar system. The first signs of an exoplanet were actually observed way back in 1917. Although this early finding did not gain much attention at the time, scientists later became captivated when their first real detections were confirmed in 1992. Then, in 2003, the persistence of another exoplanet, distinct from those found in 1988 and 1989, was officially demonstrated. As of April 1, 2024, there are now 5,653 confirmed extrasolar planets across 61 planetary systems. Remarkably, 89 of these systems have been verified to contain more than one planet. These fascinating planets are often found orbiting what are known as M-type stars. Before diving into what these stars are, it's important to understand the term red dwarf. A red dwarf is the smallest type of star in the main sequence and is, interestingly, the most common type of star in the Milky Way galaxy. It's also the closest kind of star to our own Sunday. Red dwarfs don't emit much light, which makes them harder to detect even though they're everywhere in space. Depending on their brightness and size, these stars go by various names. For instance, M-dwarf or M-type main sequence stars are so named because their maximum temperature reaches about 3,900 Kelvin, and that temperature range determines their specific characteristics. We currently know that Proxima B has a mass approximately 1.07 times that of Earth and completes an orbit around its star in just 11.2 Earth days. In comparison, Earth takes 365.25 days to complete one full orbit around the Sun. Proxima Centauri, the host star of Proxima B, is surprisingly dim, emitting only 0.16% of the Sun's brightness across the full electromagnetic spectrum, and just 0.056% in the visible light range. Over 85% of the energy from Proxima Centauri is emitted as infrared light. The discovery of Proxima B, which orbits only about 0.04856 astronomical units (AU) from its star, was first made public in 2016. So why is there so much global interest in Proxima B, given a universe filled with millions of other stars, planets, and galaxies? The answer lies in its proximity. It is the closest known exoplanet to our Sun, located just 4.2 light-years away, a remarkably small distance when measured on a cosmic scale. Furthermore, Proxima B is part of the Alpha Centauri triple star system, which is among the brightest star systems visible in the night sky, ranking third after Sirius and Cannabis. What makes Proxima B even more fascinating is the possibility that it might be habitable. It exists within the so-called habitable zone of its star, the region where conditions might be just right for liquid water and, potentially, life. This opens up countless possibilities, which is why astronomers are so deeply invested in exploring the potential of what this nearby star and its planet can reveal. The James Webb Space Telescope, also referred to as JWST, was designed with four main goals in mind: to search for light from the first galaxies and stars formed after the Big Bang, to study how galaxies form and evolve over time, to investigate the formation of stars and planetary systems, and ultimately, to better understand the origins of life itself. From the ongoing search for extraterrestrial intelligence to the broader mission of exoplanet exploration, these projects are inching ever closer to achieving the dream of discovering extraterrestrial life. With the JWST continuing its detailed exoplanet research, the journey of cosmic discovery presses on. Let me know what you think in the comments box. And if you enjoyed this video, remember to like and subscribe.